Now we're going to transition to elimination reactions. And one of the first things that I want to talk about is how elimination and substitution reactions are in competition with one another. For example, if you have this organobromide in the presence of OH minus, you can get both substitution and elimination products. So what the big focus of the rest of this chapter is going to be is to understand elimination reactions and then figure out how to differentiate whether the mechanism is going to go through an elimination or a substitution. First, let me just show you the difference with this simple example. So in a substitution, we know what happens. We take the hydroxide, which is a nucleophile, add that to the carbon containing the leaving group, and it leaves. What we end up with is the bromine substituted with the OH group, and then we lost Br minus. Now for the elimination, what's going to be different is you're not adding anything to the molecule. We're actually eliminating hydrogen and a leaving group. So in this case, I'm going to find a hydrogen on the carbon next to the leaving group. So here is the leaving group carbon. I can pick either of these carbons next to the leaving group, and I'm going to draw in one of the hydrogens. What happens in the elimination is instead of acting as a nucleophile, like it did up here, the OH minus will act as a base. And it will go and take this proton next to the leaving group. Those electrons will come down to form a pi bond, and then we'll lose the leaving group. So we form an alkene, plus we get water, plus the bromide. So in an elimination, you're not adding anything new to the molecule, you're actually losing two things, the H and the Br, and that leaves you with a double bond in the product.